Welcome to this P1 walkthrough, May 2023. Okay, so first thing to do with this question is take everything to one side. Okay, then once I've done that, to simplify, so I've got 4x squared. The minus 3x and minus 4x is minus 7x, and plus 7 minus 9 is minus 2. Okay, then I need to, either factorize or use the formula. Now, in this case, it will factorize. So 4x, so this is 1, 2, minus and plus. So this gives me 4x squared minus 8x plus 1x is minus 7x and minus 2. And like I said, you could have just used the formula here for this one. Okay, so from this point I can get kind of my two critical values. So my critical values are 4x plus 1 equals 0 and x minus 2 equals 0. So this is x equals minus a quarter or x equals positive 2. Now those are my critical values. And from here, I need to do a quick little sketch. Now it's a positive x squared. So it's going to look like a U shape, and it's going to go through minus a quarter and plus 2. Okay, so 2 minus a quarter. Okay, so that's the important bit. Now this is greater than or equal to 0. So it means I want everywhere where the line, my x squared line, or 4x squared, is above the x-axis. So that is above the x-axis here and here. So that means I want that way greater than or equal to 2, and this way less than or equal to minus 4. Okay, so my answers are x is greater than or equal to 2, or x is less than or equal to minus 1/4. Okay, so you need to show that just to make sure you get your full marks there. And these two separate inequalities because it's separate inequalities. Okay, you've got two separate regions. Okay, question 2. So a rectangular sports pitch, length x, width y, where x is greater than y, given that the perimeter of the pitch is 350 meters. Write down an equation linking x and y. So perimeter means 2 lots of the length plus 2 lots of the width. So 2x plus 2y equals 350. Now, given that the area is this, so the area is going to be x times y equals 7350. And then part C is hence find the values of x and y. So I want to rearrange this. So this could be written as 2x equals 350 minus 2y, or x equals 175 minus y. So that's what I'm going to substitute in. So 175 minus y times y equals 7350. So it's 175y minus y squared equals 7350. Take everything to the right hand side and we get y squared minus 175y plus 7350. And then factorize, so we get y minus 105 and y minus 70. Okay, now you can kind of cheat with the factorizing. You can use your calculator to find the answers and work your way backwards. So we got two answers, 105 and 70. Now x is bigger than y, so y is the smaller one, therefore y equals 70. And of course I multiply 70 by 105, that gives me the 7350, doesn't it, for here. So one of these is 70, one of these is 105. So if y is 70, x is 105 there. And those are my final two answers. Now, question 3. We've got to complete the square here. So first we want to factorize out the 3 that's in front of the x squared. So take the 3 out. And I get x squared plus, and if I've taken 3 out of the 12x, we get 4x plus 13. So I don't bother factorising out to the 13. Okay, I just want the x squared and the x term. Okay, the x squared and the x term. Now, if I go on to the next line, then everything's going to stay the same outside of the brackets. So the 3 and the plus 13. But inside the brackets, that's where it's going to change. That's where I'm going to complete the square. So I'm completing the square on the x squared plus 4x. So that's going to be x plus 2 squared minus 2 squared. Okay. So that means I've got 3 outside, x plus 2 squared minus 4 times by the 3, so 3 times x plus 2 squared minus 12 from 3 times minus 4 plus 13, so we got 3x plus 2 squared plus 1. Okay, so my a is 3, my b is 2, and my c is 1. And that's part A done. Now part B is hence sketch this graph. So I'm going to look at the sketch. Now the 3 outside that bracket isn't going to make that much of a difference to a sketch. It's just going to make it a steeper bit on the graph, but it's not going to actually change your sketch, because your scale, you don't write down your scale, so it'll just look the same as if it wasn't there. Okay, so x plus 2 inside the brackets means it's 2 squares to the left, so you've got your standard x squared graph touching and going through the point 0, 0 at its minimum. We're moving it 2 to the left and then 1 up. So it's going to look like this. So 2 to the left and 1 up. So it's 2 minus 1. It crosses the y-axis at 13. Okay, so it doesn't cross at plus 1, because if x is 0, then it's 2 squared is 4, times 3 is 12, plus 1, 13, which is my original here. Okay, so that's 13, and then that's the y-axis, 0, and the x-axis. Okay, so we've got the coordinates of the y-intercept, the coordinates of the turning point. Okay, shape of the graph, axes. Job done. Okay, question number 4. We've got to write this in terms of an indices. So first thing I want to do is write it as a separate fraction. And this is going to be the cube root of 8x. Now, I normally do this in one go, but I'm going to do it in 2 separate goes. So I've done that, first split them up, and then I'm going to write them all as indices. So 5x squared over 2x to the 1/3 plus x to the 3 over 2 over 2x to the 1/3. Now that's 5 over 2, and then looking at my indices, then 2 and 1/3, let's divide, so I need to take away, so 2 take away 1/3 is 1 and 2/3, or 5 over 3, plus, now this is 1/2 x, and 3 over 2 minus 1/3 is 7 over 6. Okay, so that's my A, B, P and Q. Now part B is hence find dy by dx, so differentiate, so that was part A. Part B, dy by dx equals, so bring the 5 over 3 down, that's times by 5 over 2x, and take away 1 from the top, so it's 2/3, plus 7 over 6 times 1/2, and take away 1, that's 1/6. So that's 25 over 6x to the 2/3 plus 7 over 12 x to the 1/6. Okay, so question number 5. We've got OA and CD are perpendicular to OD, so both of these are 90 degrees. AB is an arc of the circle. Center O, radius 4, so that's 4. BC is parallel to OD, so these are parallel. OD is 6 meters. OA is 4 meters and CD is 1.5 meters. Right, so show the angle OAB. OAB is 1.186 radians. So it's AOB. So we're finding this angle here. So how I would do this is I would put this here, so this is 1.5. That's a right angle. So I just redraw it up here. So 1.5, 4. So I'd find this first, so opposite over, so sine theta, and I call this alpha, and that theta then. So sine theta is 1.5 over 4, so theta equals 0.3843967745, just putting down the full values in the calculator there, and then alpha, which is what I want to find, is 90 minus that theta. So we've got pi by 2 minus the theta, and we get 1.186399552, or 1.186 to 4 significant figures. Now there are other ways you can do it, I'll just show in black, but if this here is my theta, then this angle here is alpha. So I could have just done cos alpha equals 1.5 over 4, and then alpha would have been 1.186 straight away. Okay, but of course, like in an exam, you don't always spot everything straight away, so just do it how you feel more comfortable doing it. Okay, now next we need to find the perimeter. So the perimeter is going to be 4 plus 6 plus 1.5 plus this distance and this distance. So I'll call this arc length AB as L, and L is our theta, which is 4 times 1.186, which is 4.744. Next is to find BC. So again, now I'm going to take my triangle, and what I want to find is this length here. So it's this length at the bottom, and then 6 minus that will be my answer. So I can do this with Pythagoras, I could do this with trigonometry, it doesn't really matter, but I'm going to call this x. So x squared is equal to 4 squared minus 1.5 squared. So x is 3.708 to 4 significant figures there. So BC is 6 minus x. So 6 minus x is 2.291. Now 2.292 to 4 significant figures. So my perimeter is 6 plus 4 plus 1.5 plus 2.292 plus 4.744, and that's 18.536, or 18.5 meters to 1 decimal place there. Sorry, to 3 significant figures, as in the question. Now, part C is find the area of the garden, given your answer in square meters to 3 significant figures. Okay, the area of the sector is a half r squared theta, or a half 4 squared times 1.186, and that's 9.488. So that gives me this area here. Next I need to find this triangle and then this rectangle. So area of triangle, that's triangle OBE there for you guys. So that's base times height divided by 2. So the base is x, so it's x times 1.5 divided by 2. Now I always, while I'm doing these like values like this, I save in my calculator so I can just reuse them again. So this then gives me 2.781, the 4 significant figures there, and then area of rectangle BCDE is 1.5 times BC. Again, I've stored this value in my calculator, but so it's just easier to use. So this gives me 3.437 but 4 significant figures there, and then it's just totaling them all up. So my total area there gives me, so total area 15.7 meters squared to 3 significant figures. So that's just totaling this, this, and this. Okay, nice and easy. So first 5 questions down, nice and easy, straightforward so far. Let's go on to question 6. So square the first, now twice the product. So the product is r times 1 over r is 1. Obviously it's a minus 1 over r, so minus 1 times 2 minus 2. And then square the last, so plus 1 over r squared. So that is part A done. Now part B is write this in the form P plus Q root 2. So it's really just rationalizing this. So times top and bottom by 3 minus 2 root 2. So 3 minus 2 root 2 on the top. And then we get 3 times 3, which is 9. And then 3 times minus 2 root 2 and 3 times plus root 2 root 2 will cancel out. And then we got the 2 root 2 times minus 2 root 2. So that's going to be minus 2 times 2 is 4, and root 2 times root 2 is 2, so minus 8 there. So that's going to give me 1, so the answer is 3 minus 2 root 2. Okay, part C. So I'm looking at this, and I'm going to start with the left hand side. So the left hand side is root 3 plus 2 root 2 minus 1 over root 3 plus 2 root 2. And then I'm going to square all of that, because that is this form, yeah, where r is my root of 3 plus 2 root 2. Now that is simply this expanded. So that means r squared is 3 plus 2 root 2 minus 2 plus 1 over r squared is 3 plus 2 root 2. And 1 over 3 plus 2 root 2 is this. So we get 3 plus 2 root 2 minus 2 plus 3 minus 2 root 2. Which gives me 6 minus 2, which is 4, and then square rooting gives me the 2, and that equals that. So it's this bit here squaring it. Yeah, so that was the left hand side squared, and then we square rooted to get just the left hand side and then back down to the right hand side. So that's basically how I did it. Now I'm sure there's a few other ways in which you can do this one, but that's how I did it. Right, question 7. Okay, question 7. So first part, we've got to find out what A and K are, and we're given the area of R1. So 0, 0 there, A, 0 there. Now, when y equals 2, we find this one, when y equals 2. So it's 2 equals 10 minus 2x. 2x equals 8, x equals 4. So that is 4, 2 there. Sorry, that's a 2. And then when y equals 0, 0 equals 10 minus 2x. 2x equals 10, x equals 5. So this is 5, 0. So our coordinates are just rewrite this one. That's A, 2 and 4, 2 at the top, and 0, 0 and 5, 5 at the bottom. So area of a trapezium is A plus B. So that's 4 minus A plus 5 divided by 2 times by the height, which is 2, and that equals 27 over 4, which is given to me here. Now the 2's will cancel. So that's 9 minus A equals 27 over 4. So A equals 9 over 4. Now we know this coordinate here now, which is 9 over 4, 2, and that is on this line. So y equals kx, and we know when x, or the coordinates 9 over 4, 2 is on this line. So when y is 2, x is 9 over 4. So k is 8 over 9. So therefore A is 9 over 4 and K is 8 over 9. And that's part A done. So I can put them on here. That's 9 over 4 and y equals 8 over 9 x. So for part B now is to define R2. So it's going to be less than this one. So y is less than or equal to 10 minus 2x. X is greater than, now it's dashed line, so it's not equals, it's greater than 9 over 4, and y is greater than or equal to 8 over 9x. Okay, because it's above this line, it's below this line, and it's above this line. Okay, question 8. So, to be able to find the equation of a straight line, we need the gradient and 1 point. So the gradient can be found with dy by dx. So it's going to be 3 over 4 x squared minus 4x to the minus, oh hang on, sorry, scratch that, that's already a minus a half, so bring down the minus half, so it's going to be plus 4x to the minus 3 over 2. Okay, so just differentiating this, bring the 3 down, take 1 away, so 3 over 4 x squared, bring the minus a half down, so that gives me plus 4, take 1 away from minus a half is minus 3 over 2. Now I substitute my value in my coordinates, so the gradient when x is 4 is, so when x equals 4, dy by dx equals 3/4 of 4 squared plus 4 times 4 to the minus 3 over 2. So that gives me 12 plus a half, or 25 over 2 there. So 12.5 or 25 over 2. So that's my gradient. Then y minus y1 equals mx minus x1. So y minus, no, not 4, 12, 25 over 2 x minus 4. So I'm just substituting in this coordinate and this gradient. Now I've got to leave it in this form, and that's what I would be aiming for even if it wasn't there because of the divide by 2 here. So what I do is multiply up by 2, so I get 2y minus 24, and I also expand the bracket at the same time. Now we've got rid of the 2, so it's just 25x minus 100. Now because it's ax plus by plus c, I always take it to the side where x is positive. So that in this case is the right hand side, so 25x minus 2y minus, now I'm adding the 24 on, so it's minus 76, and that equals to 0. Okay, part B. The curve with equation y equals f of x also passes through this point, given that f dash of x, so f dash of x is it's differentiated, so we need to get to f of x, we need to integrate. Okay, so we need to integrate 1/4 x cubed minus 8x to the minus a half. So add 1 to the power, divide by that new power. Add 1 to the power, so it becomes a half, divide by that new power, and then plus c. So I get 1 over 16x to the power 4 minus, now 8 divided by a half is the same as 8 times 2, so 16x to the half plus c. Now since this point is a point on the line, so this is now my y equals, then I can find out what c is. So when y is 12, x is 4, so 1 over 16 times 4 to the power 4 minus 16 times 4 to the half plus c. So we got 12, 16 minus, now 4 to the power half is 2, so that's minus 32 plus c. So c equals 28. So my equation is 1 over 16x to the 4 minus 16x to the half plus 28. Okay, and that is it done. So this is about recognizing the graph. So going down here, so starting like at 1 to minus 1 to plus 1, going through pi and 2 pi, so that's going to be cos, but because we're going from 3 to minus 3, it's going to be 3 cos. So A is f of x equals 3 cos x. There's x there. Now part B is on a separate diagram, sketch f of x plus pi by 4. So that is going to move my graph pi by 4 to the left. Okay. So I'm just going to put this here. Okay, now originally it was there, the x-axis, but since I'm shifting this all to the left, it's like moving this to the right. So it's going to be, oh, sorry, it's going to be like that. Okay, so that's what I've got now. Now this will be here, will be at minus pi by 4. Okay, and we got between 3 and minus 3. So all these points now are moving down by pi by 4. So if I look up here, that's pi by 2, yeah, which is minus a half, minus pi by 2, and we're going to move it by a quarter, so it becomes 3/4. So this now is minus 3 pi by 4. Okay, this one here was crossing at 3 pi by 2, 1.5 pi, or minus 1.5 pi. So it's minus 7 pi by 4. And then that's going to go up and over, and down here is going to be my 2 pi, minus 2 pi. And going the other way, this one here was at crossing at pi by 2, it's now crossing at pi by 4. Because it's pi by 2 minus that pi by 4. This one was crossing at 3 pi by 2 minus pi by 4 is 5 pi by 4. Okay, and then we've got 2 pi here. Okay, so moving it over, oh sorry, this will not make a peak again, and this one will peak over that way. Okay, so it's just moving it all by pi by a quarter and finding out those values. Now in the question it says clearly showing the coordinates of all the points the curve intersects. So get rid of that. So I've got all the points the curve intersects except for the y-axis here. Okay, and that's when x equals 0, So that means that my 3 cos pi by 4. So putting that in the calculator, 3 cos pi by 4 is 3 root 2 over 2. And that is the sketch done then. Okay, so A and B for part 1 done. Now part 2. Now part 2 is the shape of a sine graph. Now instead of there being one complete graph between 0 and 2 pi, there are 2 complete graphs. So that means we're looking at, for g of x, this is going to be a sine 2x, because there's 2 complete graphs between 0 and pi and 2 pi. Okay, now second one now looks like a sketch. So it's just minus 2. So it's the same sketch, just below the line. So if I think of first doing this here, so so 1, 2, and then going the other way. Just doing this very roughly here, like that. So that's the graph, but then I extend this up here and draw my line up there. So that's where 0 is. It's been reduced by 2. So the one that was the peak here that was at 1, removed down to 2, will be at minus 1. This will be minus 2, and this will be minus 3. Okay, because this then, if you will, would have been where the graph was before. Okay, and that's it. Ignore the black line though, but yeah, that's it. Question 9, easy marks, I'd say, and probably, you know, given the rest of the questions, if you make some mistakes here, probably not the end of the world. Right, let's get on to question 10, final question. Okay, final question, question 10. Let's expand this here, which is the curve. So you got minus a quarter x squared minus bx plus 2x minus 2b. So minus a quarter. There we are. Okay, so that is y for C there. Now we've got to find the line L1 has a gradient of a half intersects C on the negative x-axis and at the point P. So negative x-axis and the point P. Write down an equation for L1. Okay. There wasn't much need to do the expanding there. So these two mean that this is at minus 2 and this is the coordinate B. So L2 is, or L1 I should say, So y equals a half x plus c. Now, when x equals minus 2y equals 0 is one of the coordinates, so 0 equals a half times minus 2 plus c. That's minus 1 plus c, c equals 1, so y equals a half x plus 1. So that is a part 1 done. Okay, part 2, sorry. Find in terms of b the coordinates of p. So p is when L1 and C intersect. So that is when minus a quarter x plus 2 x minus b intersects with a half x plus 1. So this is a half x plus 2 if I factorize out. And this is minus a quarter x plus 2 x minus b. So now these two will cancel out. And if I times by 4 or by minus 4, then x minus b equals minus 2. So x equals b minus 2. So that's the x coordinates of p. And then substituting into L1, so y equals a half b minus 2 plus 1. So it's a half b minus 1 plus 1, or a half b. So that's my y. So my coordinates of p are b minus 2 half b. And that is the coordinates of p. So L2 is perpendicular, so its gradient is minus 2. And we know it goes to the point P, so find terms, So y minus y1 equals m x minus x1. So y minus a half b equals minus 2 x minus b minus 2. So y minus a half. I think what I'll do is I'll multiply everything by 2. Just to get rid of that half b. Okay, so minus 4x minus plus 4 times b minus 2. So 2y minus b equals minus 4x plus 4b minus 8. So it's 2y equals minus 4x plus 5b minus 8, or y equals minus 2x plus 5 over 2b minus 4. I've actually done part C. So let's turn this into part C. So what did part B want us to do? Find an equation another way. So using the coordinates b0 and m is minus 2. So y minus 0 equals minus 2x minus b. So y equals minus 2x plus 2b. So that's what b was. A bit more straightforward. Sorry about that. D, hence or otherwise, find the value of b. So these are two equations for the same thing, so we just need to equate them now. So minus 2x plus 5 over 2b minus 4 equals minus 2x plus 2b. So the minus 2x will cancel. So 5 over 2b minus 4 equals 2b. So taking the 2b's to one side, 5 over 2 is 2.5b, isn't it? So that's going to give me a half b equals 4, b equals 8. And that's all there is to it. And so otherwise find the value of b. There we are. Okay, so job done. Hope you found this video useful. If you did, don't forget to like and subscribe. And see you in the next one.